Assalamualaikum warahmatullahi wabarakatuh. Right, so now we take a look at the next example for projectile motion. Okay, example 4.4. A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second as shown in the figure. The height from which the stone is thrown is 45 meters above the ground. How long does it take the stone to reach the ground? Okay, so now we have an example of, I can say, as a full projectile motion lah, where a stone is thrown at an angle of 30 degrees, right, with an initial speed of 20 meter per second. Okay, so this speed 20 meter per second is at angle of 30 degree. So what happens is that the stone will then have two motions lah, kan? It will move forward, okay, and in the same time it will move upward in the forward direction, right, until it reach maximum height, okay, and then it will still keep move forward since forward motion is constant, kan? The speed for for forward is constant, so the stone will keep moving forward sampai bila-bila lah. I mean some until something block it. Usually when it hit the ground lah, kan? So that will stop the motion. Okay, and as for upward motion, it will go up until speed equals to 0, and then it will go down. Okay, so it will go down and keep forward, keep move in a forward until it reach the ground. Okay, when it reach ground, is before that it's still moving forward sebenarnya. Okay, because the window ni is not big enough, so I cannot show full projectile lah. Right, so by right, the motion will be until it reach the ground. So it's supposed to be outside of the window, kan? But by right, the motion should be, if let's say, if I draw like this, okay, so the motion should be like this. Okay, where it will still move forward and also downward. Right, so this is then a projectile motion lah, kan? So right, so the question asking for how long does it take the stone to reach the ground? Okay, so how long means the question asking for time. Okay, so when we want to solve projectile motion, we have to analyze it separately between the x component and the y component. And in fact, actually, we can solve it as it in y motion or as it in x motion. Okay, so we cannot. The tip to answer the question is to separate between these two axes lah, kan? So it will make the problem easier. Right, so the information given in the question is that the distance, right, x and y initially at 0, okay, and then as the stone is fall down, it has moved, even though it goes upward initially, and then it goes down, okay, but in terms of displacement, initially the stone was here and then it goes down, so it will have a displacement from here to here, which equals to negative 45, okay, or 45 meter downward. And then acceleration, even though it's not given, you can always put this into the information, kan? Because gravity is always exists, so ay is always negative g, and then initial speed equals to 20. So this is the resultant speed. Okay, so since we have to analyze it in terms of x and y, so this component v ni we have to keluarkanlah, kan, the component of x and y. Okay, so the x component is vi cos theta and the y component is vi sin theta. Okay, so 20 cos 30 equals to 17.3 and 20 sin 30 equals to 10 meter per second, which means, right, we can draw, right, the component of the stone tadi. It will have, okay, it will have y component, so vi just now, sorry, viy equals to 10 meter per second, and then the x component vix equals to what just now, 17.3, okay, equals to 17.3 meter per second. Okay, so how long does it take the stone to reach the ground? Basically, we can solve it by using the y component lah, kan? Because x component is only for keeping the stone moving forward. Okay, what caused the stone to fall down is the gravity, which is in y-axis. So, which means we can analyze it in terms of y-axis. So by y-axis, we use y equation lah, kan? So basically compare all the equation that we have learned previously with the information given and see what is matched, which means what equation can match the information given. So from all the equation, alright, including the time lah, kan? Make sure that the equation have VIY, ada AY, and then ada Y, okay, and then ada Y naught, and also have T, okay. So from all the equation, we find that this equation is suitable, okay. Y final minus Y initial, it has Y, okay. Y initial it has, Y final it has V initial, and also it has T. Okay, so since we want to find T, kan, so this equation is suitable. So put all the values right inside the equation, and we get T equals to 4.22 second. Okay, so just like chapter 2. Right, next B, what is the speed of the stone just before it strike the ground? So speed ni means it want the resultant speed lah, kan? So going back to the figure, or maybe I can just draw a new one lah, kan? Right, so right, so let's say this is the path of the stone when it reach the ground. So this is the ground. So the stone nanti will have a component of Vy. So this is Vy final, and also it will have Vx final, which is we have learned previously equals to Vx initial. So this is we already have the answer lah. Kan, this equals to berapa tadi 10 kan, if I'm not mistaken. Okay, so the speed that the question 1 ni is actually the resultant, this one. So find V final ni. Okay, so to find V final means we have to find V initial, V final Y, and also Vx we already have lah, kan? Check betul tak? X is 17.3 silap. Okay, so X is 17.3. So we need to find Vy. Okay, and then once we find Vy, we already have Vx. So theorem Pythagoras kan dia. Then we can find V final. Okay, right. So to find V final Y. Alright. So we use this equation Vf equals to V initial Y equals minus GT, right? So put in the values. So we have Vy equals to negative 31.3 meter per second. Okay, so Vx we already have 17.3 just now, right? So put this value into theorem Pythagoras. Then we can find the resultant V, which is 35.8 in. Okay, so again, if you have any question, please let me know. If you don't have any question, then please do the exercise, this one. So pause the video. Actually, the video will end here. All right. This is the end of projectile motion. In next video with a different topic lah. Okay, so please try the exercise. If you have any problem, please let me know. Okay, thank you. Assalamualaikum.